Welcome to the presentations of the subject ETF 3513 Technology and Management of Food Waste. Here we are going to present you on the potential values of food waste by granting them a new product values rather than being discarded in the landfill. The topic for this group is apple peel vinegar, which were presented by me, Chengwenya, and Jacqueline. Around 60% of food waste are coming from fruit and vegetable waste, which mostly comprise of skin, rind, seeds, and pomace, which are all good sources of valuable bioactive compounds such as carotenoids, polyphenols, dietary fibers, vitamins, enzymes, and oils. These other chemicals have a potential value in the applications of functional and enriched food, medicines, and pharmaceutical development. This application of turning waste into valuable products is an important step for the communities toward the development of a sustainable future. Not only wasting food will produce greenhouse gases, the production of food itself also involved in the CO2 emission, which is why many hard work need to be done to reduce the emissions of greenhouse gases. And this is our prototype, apple peel vinegar, which is vinegar made up from apple peels. It is a biodegradable green chemical. The production of this vinegar needs to go through two-stage fermentation process, which is alcoholic fermentations and acetic fermentation. During the first stage, the wild yeast will consume the fermented sugar and convert it into alcohol, which the alcohol will then be fed to the acetic acid bacteria for the metabolism in the acetic fermentation. And vinegar is the final product after all the alcohol is converted into acetic acid through the acetic acid bacteria metabolism. And the purpose of choosing this prototype is to increase the value of apple scrap by producing functional products.
Firstly, all the apple peels were placed into a sterilized glass jar. Then, about 1 cup of the non-chlorinated water was poured over the apple peels, leaving several inches of airspace at the top. The non-chlorinated water was used as chlorinated water will kill the microbes that ferment the apple peels. 1 tablespoon of granulated sugar was then added to the water, followed by stirring. Sugar helps to feed the beneficial bacteria and yeast that will ferment the mixture. Then, the mixture was stirred every day or every few days to make sure that all the apple peels were submerged or they might go moldy. The jar was covered with a brief tablecloth and secured with an elastic band. Brief tablecloth is crucial in accessing air while keeping out any unwanted dust. The jar was then kept in the dark cupboard at room temperature. In the next few days, the liquid bubbles were found floating on the top, indicating that the acetobacter species was converting the sugar to create vinegar. After a few weeks, it had an acidic smell, followed by bubbling stop, and the floating apple peels sank to the bottom. The vinegar had completed the first stage and was ready for the next stage. The jar continued to be left in the dark cupboard for 2 months to develop a tart vinegary flavor. After testing and the vinegar was acidic enough, the apple peels were strained out for composting using a coffee filter bag. The filtered vinegar was stored in a new sterilized glass jar with a lid. The second stage was complete. After a few weeks of storing, a vinegar model was found. It is a gel-like material made of cellulose and acetic acid bacteria that develops during the fermentation process. The vinegar is produced by these organisms in conjunction with oxygen.
And here we have the advantage of this prototype, where it is environmental friendly, as it does not contain any chemicals. It is also more odorant pleasant than most of the white vinegar on the market, and it can be act as a chemical for cleaning purpose. It is household friendly, and it does contribute in the circular economy. As for the limitations, it is very time consuming, and it consists of several uncertainties, such as it would be hard for a household user to identify its acidity level, which the acidity level is the indicator of the growth of microbes. The application of this prototype will contribute a lot in the circular economy, where the production of waste is reduced to the most minimum. The use of apple peels in producing vinegar would create an additional values and chance for the fruit waste to stay in the circular economy. And by the end of the fermentation, the apple peel could be transformed into tea fertilizer for plant composting. This entire cycle would maximize the use of apple waste at its best, though there might be some improvement that may be done to obtain better quality products, which are having a standard fermentation ratio, taking account of temperature changes during the fermentation process, and having more in-depth research with professionals.
These are all the references. That's all from us. Thank you for watching our video.